I wouldn't be talking for 40
Hi, grade 12s. Today we are going to take a look at set notation, and we're going to talk about what a set is. When we use the word set, we mean a well-defined group of objects. Every element or every object in the set is called a member or element of the set. The word element is the more common phrase. So member is appropriate, member works, but element is more appropriate. A pair of braces is used to designate a set with the members listed or written inside the braces. The braces mean the set of or the set whose members are. Now, this is the first lesson of the course, but there's something important that needs to be said. When we write a set, you have to use those brackets. If you don't use those brackets, it's not a set. On your provincial exam, there will be a half-mark communication error if you don't use those brackets when you have to write a set. So whenever you write a set, you have to use those curly brackets, not regular round brackets, not square brackets. You have to use those brace brackets when talking about a set. Always, 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 always use those brackets when you're using talking about a set. Josh has a question.
Can it just be the brackets that are like a rectangle, like half a rectangle? Or does it have to have that little spike in the middle?
Has to look like it. Josh asked, could it be just square brackets, or does it have to have that little thing in the middle? It does have to have the little thing in the middle. Like, I'm definitely not the kind of person that writes these out beautifully, but if I was to write those brace brackets, they'd look something like that. Those are the types of brackets we need to use when we talk about a set. Have to. You can't use other brackets. I mean, you can, you're just wrong. But you have to go ahead and use those brace brackets when you're talking about a set, okay? That's one of the rules, okay? It's one of those things you have to look out for. Now, what we'll do is we'll go over and look at this here. The expression 1, 4, 9, 16, 25, 36, 49 is read as the set whose members are 1, 4, 9, 16, 25, 36, and 49. And what's the significance of that? Well, it may be described as the set of perfect squares under 50. Okay? Sometimes, not always, but sometimes it's important to know what's the significance of that set. Those numbers are all perfect squares. You could even say it's the set of the first 7 perfect squares. Good. Okay? So you can describe it, and your neighbor could describe it, and you could describe it in 2 different ways, but you could both be bang on. Now, if you say something silly like, that's the set of numbers, no, that's not good enough. Whenever we explain something, it's important to go deep if possible. Okay? It's important to go deep as possible. Just calling them numbers is silly, because I can give you 7 more numbers. What is significant about those numbers? Okay? Here's another thing. Now, today's lesson is all about kind of learning the language of sets. There is a language in sets, okay? And later in this unit, I'll go over specific symbols that are important that you know. We may not use them in class, but you have to know them because they are fair game for your provincial exam. So there's different symbols, different representations, different ways to write this, and you are responsible to know that, okay? Here it is. Capital letters are used to designate sets. So if we're talking about the set C, we need to use the capital letter C to designate the set. we wouldn't use a little c or a baby c. We have to use the capital C to designate a set. And if the set was 10, 20, 30, 40, 50, that would be just, and again, this isn't rocket science, it's just C is a set whose members are 10, 20, 30, 40, and 50. Okay? So capital letters designate sets. That's how we name a set, is with a capital letter. All right? The epsilon symbol, epsilon is a Greek letter, is used to denote that an object is a member of the set. So if we see something like 20 EC, it's not EC, but it really means 20 is an element of set C, or 20 belongs to set C. Or maybe even more simply, 20 is in set C. Okay? That's what that means. Okay? Now, if that funny looking E means belongs to, then if we have a slash through it, it means that an object is not a member of the set. So 15, whatever that is, means 15 is not an element of set C. So if there's a slash through it, it means it's not in set C. Okay? This is the very first lesson of the very first unit, but what you have to understand is some of this stuff is very important for setting the stage, and when it comes time to write your study sheet for the test and the study sheet ultimately for your exam, there are some things in here that definitely have a place on that study sheet. Okay? All right. Sets that contain the same elements are called equal sets. If you have a set and it has A, B, C in it, and you have another set that has B, A, C in it, they're equal. They're equal. All right? They're equal. Because they have the same stuff in them. Okay? That's an equal set. The elements can be written in any order, but you should never list an item twice in a set. So you wouldn't write this, okay? You wouldn't write this. Like, say, I was thinking of, let's say I was to write out, oh, I'm going to write out the video games that I played last night. Well, I played PUBG, and then I played, City Skylines for a bit, and then I went back and I played PUBG again. Okay?
You named it twice.
You don't write out an element twice. You don't. Okay? So you wouldn't write an element twice. So if something occurs twice or more in a set, you just write it once. You just write it once, okay? Sets that have the same number of elements, not the exact same elements, but the same number of elements, are called equivalent sets. 2, 3, 5, 7, 11, and 1, 2, 3, 4, 5 are equivalent sets. Why are they equivalent sets?
2, 3, 5.
Well, because there's 5 things here, and because there's 5 things here. You could have another set of black, blue, orange, yellow, and car, truck, plane, motorcycle. They both have 4 elements. They would be equivalent, but not equal. Okay? So there's the distinction of equal and equivalent sets. All right? A set containing no elements is called the null set or empty set, and is shown by doing a couple different things. You could put an O, a big O, and you could put a slash through it. That's one way of saying the empty set. Or you could use your brace brackets, either your left brace bracket, your right brace bracket, and put nothing in between. That also means the empty set. So what would the empty set be? Well,
Nothing.
what if it's nothing, but where could it apply? Well, let me say this. What if I want to make a set of what would be a good, let's say we're looking at, let me make sure I'm not wrong here. Let me say we look at the set of students in this class that are from Brochet. Well, there's no students in this class that are from Brochet. So that would be the empty set. Because there's nobody that would fit the criteria of that set. Okay? When we count, sometimes we can count everything and other times we cannot. There are 12 months in a year. So that would be something we can count, but we cannot count the number of whole numbers. If someone says to you, I know what the biggest number in the world is, okay, we'll just add 1 to it. Because now you got a bigger number. And just add 1 to that. Now you got another bigger number. You can't count the number of numbers. That goes on forever.
It's infinite.
Right? If we can count all the elements of a set, we say the set is finite because we can count all the elements in the set. Okay? The number of people that live in the world, it's a massively big number, but it is finite.
8.2 billion?
If we can't count the number of elements in a set, then that's what we call an infinite set. So that's the difference between finite and infinite. Finite we can count, infinite we cannot. Okay?
Where is that page? Oh.
Okay? So, consider the list of whole numbers. 0, 1, 2, 3, and 4. That would be,
I don't see that anymore.
that would be an infinite set. Yes, Josh?
You don't have that.
Okay. Did you have everything up to here? Okay.
Yeah.
So we'll stop there. Okay? But this number here, the set of whole numbers, would be infinite, right? Are we good with that?
Yeah.
Because that goes on forever and ever and ever and ever.
Into infinity.
Exactly. Okay.